This lecture will be talking about exponential notation, which is integral to the study of algebra. Makes your life a lot easier, but it's something that's a little bit different than what you've done in arithmetic. You should have been exposed to this in pre-algebra. However, so we're just going to do a very brief review of this. But first, can you tell me why it is that the skeleton could not cross the road? He just didn't have the guts to do it. So, what happens if we have 2 plus 2 plus 2 plus 2 plus 2 plus 2? We look at that and we think, oh goodness, am I adding 2 together 6 times or 7 times? 1, 2, 3, 4, 5, 6. Okay, 2 plus 2 is 4, plus 2 plus 2 plus 2 plus 2. 4 plus 2 is 6, plus 2 plus 2 plus 2. 8 plus 2 plus 2. Not 8 again. 10 plus 2. 12. You really like doing that? I don't. Repeated addition is cumbersome, takes extra amount of time, it's not worth it. So we multiply, don't we? 1, 2, 3, 4, 5, 6. We have 6 times 2, which gives us 12. I would much rather say 6 times 2 is 12 than I would say 2 plus 2 plus 2 plus 2 plus however many 2's we're going to be using. So just as multiplication is a short form or a quick way of doing repeated addition, what exponential notation is a fast way of doing repeated multiplication. If we have 2 times 2 times 2 times 2 times 2. Actually, I'm just going to take it down to where we're using 4 as a factor, 2 as a factor 4 times. 2 times 2 is 4, times 2, times 2. 4 times 2 is 8, times 2, to give us a result of 16. But why spend all the time, that extra writing, the extra time, the extra thinking? What have we actually said here? Well, we have 2 that shows up 4 times. Now, they're not add-ins with multiplication. You're actually demonstrating repeated addition, but these are factors. So what they're doing is we're using 2 as a factor 4 times. So this right here is exponential notation. And what exponential notation tells us is that we are using this number down here on the bottom. It's called the base. We're using 2 as a factor 4 times. And as you get to 2 is 4 times 2 is 8 times 2 is 16, as you work with the smaller exponential numbers, you'll learn to see, oh, 2 to the third is 8, 4 squared is 16, 5 to the third is 125. But let's go ahead and review a little bit of our vocabulary here with exponential notation. What I've done is I've demonstrated for you how if you have a string of multiplication where you're using the same factor, a multiple, a number of times, it's tedious and lengthy to multiply those out 2 by 2 by 2 by 2. So when you have the same factor, same number used as a factor multiple times, exponential notation right here is a way to show repeat multiplication, just like multiplication shows us repeated addition. So let's do a little bit of vocabulary with this exponential notation. And we have 2 squared. Okay, that's 2 to the 2. What this says is use 2 as a factor 2 times. That's equal to 4. And this can be read 2 squared. Now we have 2 to the third. That's 2 times 2 times 2, which is 8. And this can be read as 2 cubed. Well, that's pretty strange vocabulary to me. Where in the world did they get that from? Well, let's think back to area and volume. If you have a square, piece of wood that's 2 inches on one side and 2 inches on another side, the way you find out the area is you multiply the side times side, which is sides squared. 2 times 2 is 4. Remember that was 4 square inches. Two squared. It's where we get our squared from. It's when you use the same factor twice. It comes back to area, which is based on squares, so it's squared. And I bet you know where I'm going with this next one, don't you? And you also see why I teach algebra and not art. So if we have this thing and these dimensions here, well, that's supposed to be a box, isn't it? 2 inches wide. You know, the base of it is 2 by 2. The height of it is 2 inches. The way you find the volume of a box, length times width times height. 2 times 2 is 4 times 2 is 8. Cubic inches, remember. The volume is in cubic inches. So that's where we come up with 2 cubed, 3 squared. We talk about something being cubed when the same factor is used 3 times. Talk about something being squared when the same factor is only used twice. A little bit more here, more vocabulary, just a review for the majority of you. What we see is that we can use any number as a factor any number of times. So this is exponential notation. The x is called the base, and the n is called the exponent. What this means is you can plug in any value. Remember, we're in algebra, we're using letters to represent the fact of, we might not know what that factor is down there, what that base is, and we might not know what the exponent is, but we know that what this means is take whatever the base is and use the base as a factor. Use the base, which is x, as a factor n times. Pretty abstract, isn't it? But you'll learn to think this way. So if we have 3 to the 6th, this says use the base 3 as a factor as many times as the exponent is. 3 times 3 times 3 times 3 times 3 times 3. Now, I can't tell you what that number is. That's one where you would probably end up using your calculator because we don't use 3 to the 6th a lot. But that's all exponential notation means. You read it 10 to the 3rd or 10 cubed. 10 times 10 times 10 is 1,000. That's all exponential notation is. And we find out that there are ways that we can multiply quickly together, divide quickly together when we are using exponential notation. And we have a multiplication property, a division property, and we have the power property that we're going to talk about right now. So first, let's do the multiplication property for exponents. This is very important that you understand this. Multiplication property of exponents. And this tells us that when we are multiplying together exponential expressions that have the same base, that the shortcut way of writing this is the base remains the same and you add the exponents. Hang in there with me. Don't freak out. I'm going to show you what this means. For example, we have 2 squared times 2 squared. The bases are the same, so we keep that base. The exponents happen to be the same, but they don't have to be. So just to make it maybe a little bit clearer to you, 2 squared times 2 cubed. When we have a product of exponentials that have the same base, you use the base as a factor, and then you just add up those exponents. 2 plus 3 is equal to 2 to the 5th. Okay? Still doesn't make sense to some of you. Well, let's think. What does 2 squared mean? That means take 2 and use it as a factor 2 times, doesn't it? So 2 times 2. Now, this here says take 2 again, use it as a factor 2 times 2 times 2. 5 times. I'm sorry, 3 times 2 times 2 times 2 is 3. So what has our problem here become? It has become 2, 1, 2, 3, 4, 5, used as a factor 5 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. All exponential notation does is make our repeated multiplication less cumbersome, easy to deal with. The multiplication property of exponents tells us that if we have the same base, doesn't matter what those exponents are, but we can simply add the exponents together if we're multiplying. This is how we're going to use this in algebra. We have a problem that says I have x squared times x cubed. You have to realize that these are exponentials. They have the form of a base and an exponent. The base is the same. You add the exponents. 2 plus 3. You have x to the 5th. Just like you had 2 to the 5th power. That's how we're going to be using these exponential notation. This is how you multiply. And the second one that we're going to worry about is dividing. What rule do we follow when we use the division of exponents? So we have the division property of exponents. Now I know that many of you have taken a foreign language And it was pretty scary when you first started it because Guten Tag, wie geht es Ihnen, or Sprechen Sie Deutsch, Comment allez-vous, parlez-vous français, Habla Español, all of those things, you're saying, I don't have a clue what somebody's saying. But there wasn't anything hard about the meaning. It was just, do you speak French? Do you speak German? How are you? Do you speak Spanish? But you had to know the vocabulary. These things aren't difficult, but you have to understand what it means. Our division property of exponents is written x to the m divided by x to the n is equal to x to the m minus n. Hang in here with me. This is just a broad definition of what you do when you're dividing exponents. So let me do the same thing that I did the last time. Say that I have 2 to the third divided by 2 squared. Okay? I have a division problem that involves exponential expressions. The bases are the same with an exponent. When you have a rational expression, a division problem here, where the bases are the same, what you do is you keep that base and you look at the exponents in the numerator and the denominator. Take the exponent in the numerator, subtract from it the exponent in the denominator. 3 minus 2 is 2. How many times is 2 being used as a factor here? 1 time. So that's equal to 2. All you do, the bases are the same, you subtract the exponents. Okay. Alright, Miss Betsy, you've said 2 cubed divided by 2 squared is equal to 2. But and you showed me how you use this formula, but it still doesn't make sense to me. Okay, well let's go ahead and rewrite this. 2 cubed means what? It means that you're going to use 2 as a factor 3 times. What's 2 squared mean? That you're going to use 2 as a factor 2 times. You can cancel common factors. And what do you have left? You have 2. 2 times 2 is 4 times 2 is 8. Divided by 2 times 2 is 4. So I've done that same problem 3 different ways. This is why the division property of exponents works. The final property that we have to talk about is the power property, and then I do want to mention the zero property as well. So we have the power property of exponents. These are some of the absolutely most essential properties that you will need to be able to work with your algebra. This says if you have an exponential consists of a base raised to a power, and everything within inside that is raised to a power. You keep the base, and you multiply the exponents. For example, if you have 2 squared raised to the third, you keep the base. Let me write this in orange so it stands out. 2 squared raised to the third. What does this say? This says 2 squared, that quantity inside the parentheses, is being used as a factor 3 times. So this becomes 2 times 2 times 2 times 2 times 2 times 2, because 2 squared is 2 times 2. 2 squared, 2 times 2. 2 squared, 2 times 2 is equal to 2 to the 6th. If we wrote this whole mess out. We don't have to do that though, because we have an exponential expression, 2 squared, that's raised to the 3rd power or is used as a factor 3 times. So we keep the base and we multiply the exponents. 2 times 3 is equal to 6, so it becomes 2 to the 6th. Our power property of exponents, we begin with an exponential expression. And our problem tells us that we're going to use that exponential expression as a factor a certain number of times. So we begin with our exponential expression. We use it as a factor some unknown number of times. And our shortcut way of using this, because of what it is that our problem actually means, we keep the base and you multiply exponents. Okay? One final little thing, it's the zero property. This is just the definition. Just make sure that you understand this. Anytime that you have some thing, some number, some quantity, some set of variables that is raised to the 0 power, that answer is always equal to 1. So x to the 0 is 1. 100 raised to the 0 power is 1. Now look at this. What if we had negative 7, 8, 3, x cubed divided by z squared y to the minus 3. Piece of nonsense here. But if we have that in parentheses, raised to the 0 power, that's still equal to 1, because remember, with our order of operations, parentheses and powers, or parentheses and exponents, you have to deal with those first. So we have a single quantity here, because it's included in those parentheses, that we're raising to the 0 power, and anything to the 0, no matter how messy and ugly it looks, is always equal to 1. So chew on those definitions, work on some problems, and you will find out that there's really nothing to be afraid of with exponential expressions at all. But these, I cannot emphasize enough how essential it is that you understand that if you're multiplying expressions together that have the same base, that you keep the base and you add the exponents. The base doesn't change. When you're dividing exponential expressions with the same base, you keep the base. The base does not change. And you simply subtract the exponents. If you have an exponential expression that you're raising to a power, you keep the base. It doesn't change. You multiply the exponents. And then finally, if you have an expression that you're raising to the 0 power, whether it's a number, whether it's a combination of variables, whether it's a decimal, no matter how ugly it is, as long as that entire expression is being raised to the 0 power, the answer is always 1. So work some problems, chew on these definitions, make sure you understand what's going on, and you will do just fine.